Here we're given a curve and we're asked to find a couple equations for a couple of the tangent lines to this curve. In both cases, we're going to need, of course, the slope of the tangent line. We want to find the equation of the tangent line. And we use the derivative to get that. So let's go ahead and take the derivative of this. So the derivative of cosecant of x is minus cosecant of x times cotangent of x minus the cotangent of x, its derivative is negative cosecant squared of x. So let's clean this up a little bit. The negative 2 cosecant of x, cotangent of x, plus cosecant squared of x. So that's what we're going to use to get the slopes of these tangent lines. Let's take a look at part A. In part A, we're asked to find an equation of the line tangent to the curve at the point Q. And what we're told about Q is that it has x-coordinate pi over 2. To get the y-coordinate, which we're going to need, we plug in the x-coordinate, and we're going back to y. Y is 2 times cosecant of pi over 2, that's our x-coordinate, minus cotangent of pi over 2. Remember that cosecant is the reciprocal of sine. And cotangent is cosine over sine. So this is 2 times 1 over, the sine of pi over 2 is 1, and the cosine of pi over 2 is 0. Look at your unit circle, you'll see that. So you end up getting a y value of 2. So the point Q has x-coordinate pi over 2 and y-coordinate 2. Now we need to use the derivative to get the slope of this tangent line. So if you go back and look at the top of the screen, you'll see the derivative, y prime. So we're going to plug in the x-coordinate. We get negative 2 times cosecant of pi over 2 times cotangent of pi over 2 plus cosecant squared of pi over 2. Now earlier, not too long ago, we calculated, when we were calculating the y-coordinate of the point Q, we calculated both cosecant of pi over 2 and the cotangent of pi over 2. And we found that the cosecant of pi over 2 is 1 and the cotangent of pi over 2 is 0. So I'm going to plug that stuff in. This is negative 2 times cosecant is 1, not 0. Cotangent is 0. Plus cosecant of pi over 2 is 1. That's being squared. So this is 0, and then we're adding 1. So the slope of this first tangent line is 1. So let's go ahead and write an equation of that tangent line. So we've got y equals mx plus b. It's a standard form of the equation of a non-vertical line, or one of the standard forms. In this case, the slope is 1, so let's insert that. So this m gets replaced by 1. And then to calculate b, we use the fact that the point pi over 2 comma 2 lives on this line. So replace the y-coordinate by 2, the x-coordinate by pi over 2, solve for b, and here's finally the equation of that tangent line. It's y equals x plus 2 minus pi over 2. So we now have an equation for the red tangent line in the picture. In the second part of this problem, we're asked to find an equation of the horizontal tangent line to the curve at the point P, as shown in the picture. So let me just remind you that the derivative is of y is negative 2 cosecant of x cotangent of x minus, rather plus, cosecant squared of x. Now it might look to you like the x-coordinate of this point P is 1. I can assure you that's not the case. Maybe close to 1, but I guarantee you it's not equal to 1. To find the x-coordinate of that point, here's what we need to do. We know that the tangent line that we're looking for is horizontal. That means that it has to have slope 0. So I take the derivative and I set it equal to 0. If you look at the point P, you'll see that its x-coordinate is, well, it's definitely positive, and it's going to be less than pi over 2. Pi over 2, it's about 1.57, so it's over here. So we're looking for a solution of this equation that lies in the interval from 0 to pi over 2. So let's do this. Let's factor out the cosecant of x. Well, the cosecant of x can never be 0. So let's go ahead and divide both sides by cosecant of x. That gets rid of that. I'm left with this equation here. Negative 2 cotangent of x plus cosecant of x equals 0. Let's do this. Let's add 2 times the cotangent of x to both sides. Now remember, cosecant is 1 over sine. Cotangent is cosine over sine. If we multiply both sides of this equation by the sine of x, we get 2 times cosine of x equals 1, which tells us that cosine of x must equal 1/2. And we're looking for the solution of this equation that lies in the interval from 0 to pi over 2. And if you look at your unit circle, you'll see that that's pi over 3. So the x-coordinate of the point P is pi over 3. Now to get the y-coordinate, we go back to the original equation. Y equals 2 cosecant of x minus cotangent of x, and we replace the x by pi over 3. Remember, cosecant is 1 over sine. Cotangent is cosine over sine. And let's see, so we've got 2 times 1 over the sine of pi over 3. Look at your unit circle. You'll see that the sine of pi over 3 is the square root of 3 over 2. Cosine of pi over 3 is 1/2. Again, sine of pi over 3 is the square root of 3 over 2. So we've got 2 times, dividing by the square root of 3 over 2 is the same thing as multiplying by its reciprocal. Do the same thing in the second term. So we've got 4 over the square root of 3 minus 1 over the square root of 3, which is 3 divided by the square root of 3. And you could leave that, I suppose, if you wanted to, as 3 over the square root of 3, but let me just point out that 3 divided by the square root of 3, if you rationalize the denominator, you get 3 square roots of 3 on top, you get 3 on bottom. That's equal to the square root of 3. So the point is the point P. Has x-coordinate pi over 3 and y-coordinate square root of 3. Now remember, this line, this tangent line, is horizontal. And horizontal lines have slope 0. So an equation for this horizontal tangent line is y equals mx plus b, where m is 0. So that just translates to y equals b. Well, to get b, all you have to do is notice that on this horizontal line lives the point pi over 3 comma square root of 3. So b has to be the square root of 3. Every point on this line has the same y-coordinate. Since this point has y-coordinate square root of 3, they all have to have y-coordinate square root of 3.